Have you ever wondered how one object can push or pull another without even touching it? No magic here. This is electrostatics at work. Today's goal is simple. Predict exactly how these invisible electric forces behave, and it all comes down to how electrons move. Meet the two big players in this story, conductors and insulators. Conductors, like metals, have free electrons. Think of these electrons as travelers. They aren't stuck to one atom. They can move freely and instantly respond when an electric force shows up. Insulators, like plastic, wood, or glass, are different. Their electrons are homobodies. They stay tied to their atoms, but they can stretch and shift slightly. Let's start our bumper car race. Scenario 1. A charged rod moves close to a neutral conductor. Because the conductor's electrons are free to move, they rush toward a positively charged rod. This process is called induction. The conductor separates into regions: opposite charge near the rod and like charge pushed farther away. Prediction rule #1. When a charged object approaches a conductor, the force is always a strong attraction because the electrons can completely rearrange. Now, scenario 2, the same charged rod approaches a neutral insulator. This time, the electrons can't leave their atoms, but they can shift slightly. This creates polarization. A small negative region forms closer to the rod, while the object remains overall neutral. The electrons can't leave their atoms, but they can shift slightly. This creates polarization. A small negative region forms closer to the rod, while the object remains overall neutral. Prediction rule #2. When a charged object approaches an insulator, the force is always a weak attraction caused by internal polarization. Here's the key idea to remember. A charged object will always attract a neutral object, but the reason depends on whether the object is a conductor or an insulator. Quick check! A negatively charged balloon is brought near a wooden cabinet. Wood is an insulator, so what happens? Polarization. And that means attraction. Now you know the secret life of electrons, whether they're free-roaming travelers or homebody shifters. Use this knowledge to predict electric forces everywhere around you. Thanks for joining the race. Go explore some static electricity, and I'll see you next time.